All right, just one more minute, and we're gonna start going over this stuff. Yes. You did an inverse norm instead of a norm CDF. Because remember, you didn't have the area, you had the value.
Wait.
You were.
No, because I was clear at all.
Just need to sit down, we need to go over it. Everyone from it. Yes.
I thought 95% interval was wider than 90%.
Sorry, yes, I meant to circle A.
Okay.
Yes. Correct. It will not be as wide. All right. So let's do this first. Which I forgot to update that. What am I looking for? DYUs. I gave those back with some feedback. What I want you to do on your day off tomorrow is go through it. I'll upload a video going through it so that you know if you still need to ask some specific questions. So honestly, overall, we did a phenomenal job on a lot of the DYU, especially multiple choice. Where we hurt ourselves on the DYU is, I need you to remember, so go look at the free response for the DYU quickly. So pause for a second, look at the free response, number 16. I understand that it only says construct and interpret, but I told y'all this in class. On the AP exam, if it says construct and interpret a confidence interval, what you gotta do?
Show your work. 4C.
The 4C method
4
for
Cs.
inference. You gotta choose, you gotta check, you gotta calculate, you gotta conclude. I know that they didn't say do the choose and the check, but on an AP exam, you've gotta choose, check, calculate, and conclude. All 4 of them. Every single time. Okay? So please hold on to that and keep that in mind. On the calculate portion, you've got to show some work. Yes, you can just put it into a calculator. You at least have to show the formulas and substituting into the formulas. But again, multiple choice we actually did pretty darn well.
I did really good on that.
Yeah, but we just got to be careful on a couple of details. Okay? It was that free response that hurt a lot of us, unfortunately, which I didn't want it to be that way, but it caught a lot of us because we forgot to do the 4C method of inference. Look through it, see what questions you need to email me tomorrow. Okay, really quickly, I had this question come up, and I want to talk about this and remember hypotheses. The null hypothesis always has to be a statement of what? It has to be a statement of equality. And do I need to use P or P hat?
P.
P. Remember, P equals some assumed value. The alternative is what?
P hat.
Nope, not P
It's
hat.
less than, not equal to, or greater than.
What's less than, not equal to, or greater
The
than?
value of
The P, and whatever value we had earlier.
My bad.
It's got, remember, we're collecting evidence for the alternative. We have to assume a thing based on what is already out there, and then we collect evidence before or against that. Or against that thing, that's our alternative. Remember, with a P value, this is the probability of getting a statistic at or more, what? Extreme. Assuming or given what?
Given the null.
The null is
True.
If you understand that, you can follow the formatting that's there or do whatever you need to do to make it easier for you to make sense out of it. But our p-value is the probability of getting a statistic at or more extreme given that the null is true. That's where the p-value is. Raya, you up here? Okay. So, there we go. Checking our understanding. Those were the answers that I came up with. I will say I think I should have reworded that p-value slightly differently. Where are all of my erasers? Dixie, can you toss me one of those two?
Uh-oh.
Thank you.
Good catch.
So,
Pender.
note, we have this data out there that p is 0.84. What does the school psychologist think might be true? That P is,
What, 84?
no, the psychologist thinks it might be greater,
Greater.
okay?
Ah.
Now, I didn't actually take the time to define the parameter of interest, that's my bad, but what is P again?
True proportion of teenagers who think highly of their mother.
Okay, true proportion of teens who think
Highly.
highly of mother. So was there some evidence? Well, yeah. Why was there some evidence?
The p hat was 0.88.
The question is that strong enough evidence?
No.
And we see that later, right? Which again, looking at the language that I used, I don't particularly love how the grammatical structure worked out, but do I have my parameter in this interpretation of the p-value?
Yeah.
The true proportion of students who think highly of their mother, right? Do I have the idea of the null hypothesis somewhere in there?
Yeah.
Yeah? Do I talk about the probability of the statistic being at or more extreme?
Given.
So the likelihood of getting this statistic or more extreme, greater than or equal to 0.8, by random chance, assuming the null hypothesis is true, that likelihood is this. So I hit those three elements. Those are the three things you have to hit. There is the formatting, right, that the mathematic gives you, and you can memorize it. The issue is, I hate memorizing. And there's too many formats to memorize and learn all of it. That's why I always go back to the probability of this statistic or more extreme given the null is true. As if I interpret the p-value through that lens, then I've got it. Yes, Raina?
So in the context, when you say, it says in the notes, it says, do we have statistically either enough evidence to reject the null hypothesis or doesn't have enough evidence?
Pause for a second. Are you still talking about number 3?
Yeah, I just wanted to.
That's not interpreting p-value though.
So it's in the notes, it says to include context with the null hypothesis. What kind of context it should be? So,
Raina, what was the whole question about? What is the school psychologist worried about? What was the parameter that you wrote up here?
It's great, true proportion.
That's your context. That's the point of defining your parameter. Is that's your context. Notice, that's what I'm saying. My context, my parameter is right here. The true proportion of students who think highly of their mother. That's what the statistic and the parameter is all about. That's your context. But again, be careful, because what you just talked about was the conclusion, not the interpretation of the p-value. And there's a difference. What does that p-value mean? The p-value means this. Now, is that so unbelievable that I reject my null hypothesis?
No.
No. Is it unbelievable? It's low. It's a low probability, but it's not so unlikely I reject. So the language we would say here is we, and I didn't write all the way out, but we fail to reject the null hypothesis that the true proportion of teenagers who think highly of their mother is 0.84. There is not convincing evidence that p is greater than 0.84 because p value is greater than alpha, right? So remember I told you, like, you can memorize all 4 things, but what do you have to do? Reject or fail to reject the null hypothesis. You have to have context. You have to have comparison of p-value to alpha, and you have to say there is or is not significant evidence for the alternative. You have to hit those 4 things. Yes, Star.
So if the alpha was like 0.1, like you said it could be,
Then we would have
you could
statistically
reject it.
significant evidence. And there's times on like a progress check where they'll ask, when do we have statistically significant evidence? And so like if the p-value is 0.02, you would have to recognize, hey, there's statistically significant evidence for 0.1, 0.05, but not 0.01.
Okay.
Stuff like that. Dixie and then Ian.
Why would the p-value not come before the p-hat? Or like, do you just have
You
to-
can. Yeah.
So it works either way.
Yeah, so remember, that's what I was saying here, is as long as you kind of have these elements of the parameter, just context, the, assuming the null is true, and then this probability, you're good. That's also why, because I got like 3/4 of the way through writing this and I realized it's a little bit awkward, I put commas around here to make this parenthetical, to make it clear that the likelihood of getting this by random chance is 0.091. And then I put the parameter and assumption of null hypothesis inside that parenthetical. But yeah, the format they give you will always work for interpreting the p-value. So there's a probability of 0.091 for getting p hat greater than or equal to 0.88 by random chance alone, assuming the true proportion is this. So you can do that p-value first, 100%. I just, again, I don't memorize, and for the better or for worse, I just make sure I hit these elements. Ian.
Okay, so basically when your p-value is small, like insignificant, you reject the null hypothesis.
When the p-value, so remember what the p-value is the probability of getting this statistic given the null is true, right? So if I get a p-value of 0.02, assuming the null is true, what's the likelihood of getting that statistic or more extreme? That's not this case. I'm saying if you got 0.02, what is that saying? What's the likelihood when the null is true that you get this statistic or more extreme?
Okay.
No, what is it in this case?
It would be...
No. Ian, right here. What's the likelihood?
0.02.
Okay, thank you.
Okay.
How likely is that if this is true?
Not very likely.
It's so unlikely, I don't think this is
False.
No, I don't think this is true. I think it is false. Be careful with the language. Because what I said was, I don't think this is what?
He doesn't think compass true.
Which is the idea that it is.
Oh wait, that's what, okay.
Yes,
Yeah,
that's why I was trying to be careful with the language, so pay attention to those details. It's not that I don't think it's false, it's that I don't think it is true. Okay. Alright, so here's the are you sure Miss Kowalski isn't a good free throw shooter? So here's the thing, how did we do it in lesson 1? By doing a what?
Random sample.
We did random sampling, so there's an S word that we need to know.
Standard deviation.
Standard error.
Sampling variability.
Say again. We kind of developed a sampling distribution through what process? Where we assigned the numbers 1 to 8 as successes and 9 through 10 as failures. Say it again. Simulation. Guys, we did. I heard stimulation multiple times. That's my bad. Guys, we simulated this case. Right? She actually did the case where she shot 50 times and made 32 of them, right?
Right.
Which is why we said, hey, I don't think she's an 80% free throw shooter, so we simulated this occurrence by letting the numbers 1 through 8 be a success, her making a free throw, and 9 and 10 being a failure. But here's the thing, do we want to do a simulation every time? Do we want to put all that extra work?
Maybe not.
Maybe not.
No.
So right here, in our introduction to significance test, we used a simulation to estimate a p-value to decide whether or not Miss Kowalski was exaggerating about her claim of 80% free throw percentage. She made 32 out of 50. Today, we're going to use a formula to find a p-value. So, say again.
Do we have to?
What?
I don't want to do it right.
Do what?
I can memorize another formula.
Holy crap, dude. Maybe you've already learned this formula. Maybe. Just possibly. Maybe it's even on this thing that's called a something sheet.
Okay, my bad.
That starts with an F, like a formula sheet. Okay, so
Stop work on me.
I'm going to give y'all 10 minutes to get as far through this, and I'll be coming around supporting you, but 10 minutes, and then we're going to come back and talk about this before we go to lunch. Okay?
You want to be my partner?
No, but you can join one of these two groups that need a partner.
No, but I don't want to lose Aura.
Well, then do it on your own, and then I'll check on you every now and then.
Actual aura is learning to work.
Can you sign out?
Actual Aura is finishing this by 12:08.
Whoa.
I mean, it probably is.
It's gonna be p times 1 minus 2.
How do we calculate mean and p hat? I think we have this formula really going.
1.64.
Mean is p hat,
Yes.
p hat is equal to p.
1.36.
So,
Divided by 50.
p hat is 0.8.
Yeah. You're thinking of binomial
Check it, large
random
counts
variables.
n times.
Totally.
N times p hat, so it's 0.64 and 32. So is it?
I got 0.067.
Is that right?
And what did you define P as in the hypothesis?
Correct.
That's 32 and 50.
Because it's P.
36.
The
That's
mean of
probability.
P hat is P.
Oh, no.
18?
Right.
That's 30, right?
Do you
It
put?
has to be greater than or equal to 30, right?
Alright, let's talk about a couple of details before we continue much further. So, I want to make sure that this is clear. I'm not going to go all the way through everything, so pause for a second and look at this. So, make sure you define your parameter from the beginning. P, please do notice, I do not say equals, the idea of equals is equal to a value. The colon here allows me to define something. So use a colon. They're not going to take off on the AP exam. That's just a thing for me because of how English and how statistics actually work. Anyways, P is the
Oh, break.
true proportion of free throws
Miss Kowalski.
Miss Kowalski makes.
There's glue on the bottom of my Kit Kat.
That's odd.
Oh.
Okay? Now,
Yummy.
what is our assumption?
Extra parking.
That P is less than
That's
0.8. Oh wait, I'm sorry. P is equal to 0.8.
I would say, guys, remember, null is always a statement of equality. Alternative,
That's
Did I-
less.
that's less than. Did I think she was just not different from, or did I say she was less than?
Less than.
Less than, okay. Do we have a random sample? Randa said Mr. Kinney doesn't say anything about a random
Yes,
sample.
yeah.
Simulation.
Where does it say it?
Simulation.
Now, the simulation is random, but we're talking about the P hat, her statistic. Was it random?
She just picked the ball and shoot it up.
Yes.
We can just assume.
So we'll just have to say, I'll say this, it doesn't actually say random, so you would have to make the statement, we assume randomness. Do not say it tells us random unless it actually tells us it's random. We assume randomness. Why is this important?
In order for it to have less bias.
Reduces bias.
Most accurate representation.
You don't reduce sampling variability with random.
Most accurate representation.
What
Is
reduces that?
Randomness is all about reducing bias.
What was
Accuracy.
we have to, we have to explain why we're doing randomness.
No, but I need you to understand why we have to have randomness, because it'll help you remember all the other pieces. So, gotta have randomness because that's gonna reduce bias. 10% condition.
Yes.
This is N is less than 10% of population. Technically, I think Emerson said it's an infinite population, so is 10% less than it? Yes, okay. Infinite population size. So, yes. Okay, why was the 10% condition formula important?
Because
A poppy normal.
it can
To
prove
make it
independent.
Be careful. Hey guys, I need y'all to be careful.
In,
10% has nothing to do with normality.
in order for us to be able to use this, the P hat.
It's all about independence of samples. So, these formulas
LCC
Only
is
work
normality. Let's
if
continue.
individuals
Oh.
are independent, okay? That's the 10% condition. If your sample size is less than 10% of the population, you can assume the individuals or the trials are independent. What allows us to check normality with proportions? Large counts. Now, I need us to pause and remember, because when we did confidence intervals, could we use the actual large counts of N times P?
No.
No, in confidence intervals, we had to use what?
Yeah.
P hat. Can I use N times P now, though?
Yeah.
Yes.
Why?
Because we just
Well, you
checked
have a
it.
fee.
We have a P. I need y'all to pay attention. In a confidence interval, we have no P even possible. What's our P in this problem?
0.8.
0.8. That's why you have to choose initially. You've got to pay attention to that. because we have a null hypothesis, we assume P is 0.8, we have to use that 0.8. Okay?
Oops.
So N times P, and this is why I wanted to go over that, 50 times 0.8, which is 40, which is greater than or equal to 10.
Dang it, I did less than. Mr. Kitty,
We gotta get that under control.
I did less than 3. It's right.
Oh, I looked at it,
Okay, so
Oh.
is large count satisfied?
Yes.
Yes. Guys, you gotta show the calculations. In a hypothesis test,
my.
it is expected successes and expected failures. Okay? In a confidence interval, I don't have a P, can't use P, I gotta use P hat. But the natural thing is to use P, okay? So what is the mean of P hat? Guys, we got formula sheets.
Should be
It's
40.
just like
That'd be
0.8.
0.8. Because mean
Alright,
of
that's
P
fine.
hat is P. Okay? And what was my assumed P?
Wait.
0.8. Standard deviation of P hat then. Can I use the sigma P hat or do I need to use the standard error?
Use standard error.
Why, does everyone agree we need to use standard error here?
For what?
Yes?
No.
Now I do.
Why?
Quick question. Here, we had to use P hat with confidence intervals because we didn't have P, right? With confidence intervals, we had to use standard error because we didn't have a what?
Standard deviation.
We didn't have a
Popular perimeter.
P. A P, there we go. Standard deviation of P hat is
Oh,
the
wait.
square root of P times 1 minus P divided by N. But if we didn't have P, we had to use
Standard error.
the standard error. Hey, question, do we have a P this time?
Yeah, we do.
So should I use standard error or standard deviation?
Deviation.
Yeah.
My bad, bro.
You're good. No, this is an important discussion that I wanted to have. Guys, we do need a P, or if we have a P, we use our P.
0.0566.
Make sure you slow down, write out your formula. And so what's my standard deviation this time?
0.056.
0.056. You can go more decimals if you want.
I got that.
You forgot to take your square root, that guy.
Okay. Poggers.
Okay, but that's again, Ian, why we write out our formula, because then we just are able to type it in.
I had done the standard error.
No, you did standard deviation, you did 0.8,
Oh, no,
0.2.
before that I did the standard error.
Alright. So notice it says use the mean and standard deviation you calculated to label the normal curve below. Bump that, I'm not doing all that. What am I going to do instead?
Z-score.
I'm going to calculate a z-score.
Yeah.
So instead of taking the time to label this, if I convert it to a z-score, don't I get a mean of 0 and a standard deviation of 1?
Yeah.
Okay, then make my life easy, right? Now, earlier, Star, you said, I don't want to memorize another formula, and I don't blame you. But in general, Z, I think that's a statistic, then what?
Parameter
Minus the parameter,
over standard error.
divided by standard error, but in this case, it would be standard deviation of the sampling distribution. So I always like to write out my formula, statistic minus parameter
Whoops.
divided by standard
Here's
deviation.
my calculator.
It really sounded like one, let me tell you.
Sure was.
You just said nothing else.
And so I 100% write this all the way out. So type that Z in. What?
Where did the 0.64 come from?
Because that's what.
32 and 50.
Negative
The
He
2.
had?
269.
So this is why you write out that formula: statistic minus parameter divided by standard deviation.
Oh.
And that's why I write out that Z-score each time. So you good with that? You can also write out the 32 out of 50 if you want, instead of 0.64. Yes, sir.
For number 10, are we assuming that the probability is still, or not probability, the portion,
Yeah, she still claimed that she's an 80% free throw shooter, right?
and in the previous question was asked, was still supposed to use that in my calculation?
Say that one more time. You did or did not use that in your calculation?
I'm asking if I'm supposed to use that in my calculation for number 7.
Yes. Just like p hat minus p divided by standard deviation. Okay? So, I can see this at negative 0.16 divided by 0.056 or so. But what did you get for your z-score if you type that whole thing out?
Negative 2.8284.
269.
I'll just stop there for now. Okay, so negative 2.82 is where I'm stopping. So 1, 2, somewhere in here. So right away, how likely is it that we get a 0.64?
Very, very
Or less?
unlikely.
Very, very unlikely, okay? So, by the way, number 7, how many standard deviations below the mean is p hat equals 0.64? We should have that. Yeah, so pull that over to here, negative 2.82. So find that probability. So what is the probability that z is less than or equal to negative 2.82?
0.00235.
Make sure that you type that in, but notice what am I going to use to calculate that
A
probability?
normal CDF.
A normal CDF, right? Remember, from that z-score, mean of 0, standard deviation of 1, so you don't have to change too much. So what conclusion can we make?
It's almost impossible.
It
We should
is
reject
such a-
the
So-
null hypothesis.
Reject the true the portion of zero.
We failed to reject the null hypothesis.
Oh? What?
Am I not right?
No, we
How likely is it that she only makes 32 out of 50 if she's
completely reject the
an
null
80% free throw shooter?
That's less than 1%. Like,
Remember, what this is saying is
That's
the probability that p hat is less than or equal to 0.64 given p is 0.8. How likely is it that we get this statistic if she really is an 80% free throw
Almost
shooter?
zero.
Unlikely.
Okay, so then what do we no longer think to be true?
The null.
The null. So we reject the null hypothesis because I know this sounds flipped, but we need to remember if the p-value is less than alpha, we reject the null hypothesis. It is statistically significant evidence. There is convincing evidence. The true proportion she makes is what? There's convincing evidence the true proportion she makes is
Less than 0.8.
less than 0.8. So you gotta remember, if that p-value is really, really low, that's almost impossible, so I no longer think the null is true. It's very implausible, it's almost impossible. Remember, we assumed this to be true, right? Do we still think this to be true since it's almost impossible?
What's impossible?
Yep.
Of only getting 64% of her free throws.
If she's supposed to make 0.8.
Right. That's almost impossible, so what do I no longer think to be true?
That the 0.8 is correct.
Right. Oh, that's supposed to say less than 0.8, sorry. So remember, in driving a conclusion, you either reject or fail to reject the null hypothesis. You have to compare the p-value to alpha. There either is or is not convincing evidence for the alternative with the parameter or the context in there. Do you have to do it in that same order every single time? You just have to have those 4 elements. Parameter with context, reject or fail to reject the null hypothesis, convincing or not convincing evidence, which I forgot the word evidence, for the alternative, and compare p-value to alpha. So that was very unlikely. Now, when we come back from lunch, we're going to go over the quick notes, and I'm going to quickly show you, because guess what? You got to write all this stuff out, but you know what we have available to us on calculator?
The menu.
The menu, and before, you remember how we had confidence intervals?
Oh man.
You know what there is on the calculator?
Confidence interval?
Well, we're not doing a confidence
A list of
interval.
spreadsheets.
there's that, no, guys, what are we doing right now? It's called a
Oh, it's a
hypothesis
stat
test. Oh yeah, there's statistics test or hypothesis test, so we're gonna wanna use the calculator after lunch
Oh,
for
that's
these
that
things.
calculation.
No, we'll look at it, what?
Oh, wait,
I'm
never
not
mind.
talking about it. See what it literally says,
Oh, I'm
stat test though? Okay, well.
Guys, what's this stuff going on the floor?
And I don't.
Get me out of here! I'm engaged right now. Hey, Star!
I agree.
Wait, you really kind of met you.
Yeah, I remember the cussing context.
Remember that? A little bit. Like how much?
Wrong, I don't know what details you missed.
I did back like 5 years ago. But I'm trying to find a friend to go to Oldham and Warwick.
The more satisfied for sample size of 50 to 75, you tried to use something limited. But if you have proportions, you have to use large counts.
Yeah, she probably.
Large counts.
Yeah. Trust. I got me to I was in the queue at 9. Do you work Tuesday?
Remember, sample
It's
size is
Tuesday?
75.
No.
So you
Why?
have to do, oh,
Where
shape
did
can
you
be
get that from
determined
the
because the
So I
population
dancing
was
with
a
the
possibility.
Oh.
Remember,
She's
the
got to
population
eat
was
it
a
up too.
Yeah.
I'll go.
And Brandon, your
Okay.
range was 12, not the IQR.
Mr. Kenny, do you watch Dancing with the Stars?
Much on the stat test. Here's the reality. You know, all that work we did in steps 7 and 8 where we wrote out our formula and we plugged all this stuff in. You remember all that stuff? Okay? You have to do that, but do you have to do these calculations by hand?
No.
Definitely not, okay? So, let's show how to use the calculator. And so, Talia, do you have your iPad with you?
No.
Okay. Let me just take a picture and I'll email it quickly just because I want to show the calculator stuff and we got to get through. Alright, there's that. I'll email it to you. So, calculator. Oh, that's frozen. You can't see that. So where am I going to go if I want to do cool stuff? Menu, okay? So hit menu for me. Pick up your calculator, hit menu. Or if you're Ian, one of the 7 you've stolen from my class.
I have never had 7 before.
Oh yeah, sorry, 6 on
I have 1.
Right. Okay, so menu. Where am I going to go from there?
Statistics.
Alright, so under statistics number 6.
Stat calculation.
No, stat calculations. Stat what?
Confidence intervals. Oh wait, no, stat test.
Yeah, we're doing hypothesis testing now. Any guesses which one from there?
A 1 sample probability test.
Oh, dang it.
A 1 probability z test.
1 prop for proportion.
1 prop z test.
So number 5, 1 proportion z-test. Okay. So what is this piece of 0? What does that mean?
The null hypothesis.
Okay, so what was our null hypothesis?
0.8.
0.8. What was our number of successes?
32.
32. So notice you need number of successes, not proportion of successes. Sample size?
50.
And then what was our alternative?
It was just less than 0.8.
That the true proportion was less than 0.8, the null. And hit OK. Wow.
I got error.
Did you type something in wrong?
Uh-oh, I got error.
Anybody see z-score in there? That's because you already had stuff typed into that line, dog.
2.82.
You can't go back through it with nothing typed into that line.
Now I did the
Why is it
Did you
one
do the same thing?
called
Yeah,
one?
I took it later.
You're telling me you go from 6 to
Huh?
7?
Why is it the 5 over
6,
5
7,
not
5.
6?
Well, how many proportions did we, how many samples did we have?
Oh, okay.
Yep. Like, we didn't do P1 minus P2, we just did P. Alright, Andrew, you got all that? Yeah, you just got it? Alright, so, number 10.
Charlie just got absent randomly and so abruptly.
So number 10 though, quickly write out the formula and then put it into the calculator and let's calculate and interpret the value produced so that we can move to can you taste the rainbow.
Oh.
Ooh.
I have Skittles in my pocket.
I have Skittles in cups.
Oh.
Nah!
Dog, you literally have one on your lap and one in your hand.
You're not making it better.
Wait, I don't remember this.
Guys, quickly, efficiently, put into the, write out your formula, do the calculation.
Your car.
My card is
What's
file.
up?
Is this your card?
Why'd you do greater than?
Oh. Mr. Kenny, what formula?
Well, just like we did a z-score earlier,
Oh, for 10?
for number 10, because notice now I think it's 36 out of 50.
Yeah. Oh,
Yeah.
okay. Don't worry about it.
Oh, kid, you know
Has anybody else not ever had Skittles?
What's never had school?
Wait, what are Skittles? I've never had Skittles before, Mr. Kennedy.
Yeah, I can tell you're a liar.
Okay, so like.
I don't really eat one here.
No, I'm not. I committed.
The
last time I had
Skittles.
You never had school?
Green is one, orange is orange.
Scissors.
Grape is
I've never had Skittles.
You
do
do it.
some background context
Oh, shoot.
before we do this study.
Are you a whipper? Oh, are you serious?
We're saying.
I didn't.
Stop.
Oh, 657? Oh, wait, that's 675.
That's my number.
Did I ask?
205 675.
Did I get it? Okay.
March 21st, 2034. Wait, does March even have 13 days?
Mr. Kenyon,
It
are
does.
we gonna start the lesson for
Remember that date.
9.3 today?
March
Yep.
31st,
Are we
2034.
gonna finish the notes?
Nope.
I'll be 26.
It'll be a Tuesday.
Dude, I'm ready for stealing.
Yes, Raina, we're gonna finish the notes.
Oh, really? Okay. Then
Right,
that's
Of course, we're gonna finish the notes.
What notes?
That way I need more, I need to do more homework.
I don't have any more to drink.
Crazy, see?
Oh, I need to buy the star stickers.
Did you ready for it? I did.
Can we all copy in unison? No. Okay.
According to my calculations,
This is
yes.
the first formula.
Okay.
Where's Mr. Anderson at?
He wasn't feeling well today.
And
No!
Alright, so,
I thought they him a cough drop.
okay, so, negative 1.414.
Yes.
Now, I'm gonna point this out personally. I actually didn't do any of these calculations by hand. I put it into the formula, but do you know how I got that z-score?
The calculator.
Stat minus parameter minus the standard deviation.
Minus?
D-test?
What part of the calculator? I did a what?
D-test?
I did a z-test. I did a one proportion z-test. Like, I wrote this out. Remember in confidence intervals when I wrote out the formula and I plugged everything in, and then I didn't put that formula into the calculator? Correct. I just did the stat test in this case. So I'll show you that in a second. But I do want to point out, remember how I've asked you since the beginning to draw your normal distributions?
Yeah.
This is why. If you don't draw your normal distribution out and shade, then you will not get full credit on hypothesis test on the AP exam. So a part of the calculation portion, you need to do this. Now I will say there's actually technically alternative ways, but this is the simplest. But notice how that corresponds to my alternative hypothesis and that z-score. So the probability, so like what we've done really is the probability that p hat is less than or equal to 0.72 given what to be true.
Oh, what A is true?
What is 0.8?
The null hypothesis.
So the, which population?
P-value.
Population, the parameter. You said parameter, that was my fault. But yeah, the whole idea is that, what is this probability? Well, that corresponds to the probability that z is less than or equal to negative 1.414, which, what is that probability?
0.078765.
Okay? So all of that coming out of the calculator, notice we're calling that probability a what again?
P-value.
P-value.
A P-value.
So all I did,
P-value.
right, was I wrote out my z-score formula, and I do want to remind you and hold on to this, it's statistic minus parameter, so it's the mean of the p-hats divided by the standard deviation of the sampling distribution, sigma of p-hats. And so, again, no new formula, right, Star? We're just plugging in what we already have. The number of new formulas that we have for the rest of AP stats, I think, is 1.
The cheese
Or chi-square.
Correct.
Oh, not
Yes.
chi-square.
Okay? Everything else is based on this.
like cheese.
Okay? And confidence intervals.
Easy peasy, lemon squeezy.
Alright?
Panda.
And then use that calculator to do this calculation for you. Okay, so, again, we really have to get through the next lesson for sure, since we're gonna miss class tomorrow. And so I can give you the assignment.
Veterans Day.
Yeah, tomorrow's Veterans Day, okay?
Wait, what about perimeters for a slope?
Same formula.
Oh.
There is gonna be one slight change, but yes, overall same formula.
I drive Charlie.
I lied, there is actually a second formula for when you have a difference in proportions, we'll talk about that, but it's not much different at all, it's all on the formula sheet as well. All that to say, okay, so they ask on here to interpret this p-value. So, the probability is 0.0786 that Miss Kowalski makes 72% or less of her free throws, given her true proportion that she makes is 0.8. So the probability is 0.0786. I've reported my p-value that Miss Kowalski makes what?
Less than 0.8.
He makes less than what?
I'm sorry.
Less than what?
Less than 0.8.
No, it's not that she's making less than 0.8. It's the probability that she's making.
That given
See, that's the condition. That's the null hypothesis. But what did she actually get?
0.72.
So 72% or less. That or more
Or less.
extreme of her free throws. I'll get it for you in a second. Given what to be true?
That 0.8 is true.
Given she is, or given the truth is p equals 0.8.
Should we say that assuming the null hypothesis is true?
That's the given the truth is 0.8.
Mm.
And technically, it's the probability that she gets that given the truth is 0.8 by random chance. Because it's quite possible that she gets that if 0.8 is not the truth, it's given 0.8 by random chance.
Thank you.
You're welcome.
Not
So-
you.
Thank you. Thank you.
No.
Yes,
I.
so I went to print them and I ran out of yellow paper. I'm just gonna print it out with white paper for now and give y'all yellow copies later. Okay,
Of a heart attack.
so,
Get an asthma.
hey guys, what conclusion should we make?
That we have to
Compare
wait,
it.
we have to support, we have to accept the null hypothesis.
Nope,
Oh, no, we
be
reject
careful.
You reject.
No, we never accept the null hypothesis. What do
Fail
we do?
to reject.
We either reject or
Fail
fail to
to
reject.
reject.
Which one should we do since p-value is greater
We
than
need to
alpha?
fail to reject.
So, we fail to reject
Can I TTS?
Get it.
Text to speech.
the null hypothesis. Again, why do we fail to reject?
Because the value is greater than alpha.
Since the p-value, which I include the values, p-value of 0.0786 is what to alpha?
I think you spelled feel.
Greater.
Greater than alpha equals 0.05. And if we're unfamiliar with our inequalities, we gotta work on that. That number is bigger than that number. That's why the bigger side is with the bigger number.
Are you sure?
100%. You can think that, but you're wrong.
According to my hypothesis, were we?
So we have our fail to reject the null. We compared p-value to alpha. What do we still need?
Context.
Context and one other thing.
Cause
Statement about the Oh, yeah.
We have a statement about the null, we need a statement about the alternative. Since we failed to reject the null, there is what for, kind of evidence for the alternative?
Sufficient.
There is
Plausible.
insufficient.
Plausible.
Insufficient.
Here is.
Guys, we failed to reject the null. We don't have enough evidence for the alternative. That's why we failed to reject. There's insufficient evidence that the true proportion she makes is what? Not 0.8,
Greater than
not greater
Not
than.
equal to.
7
Was
Less
it
than.
our alternative of 0.8, of less than 0.8? Remember, we're making a statement about the alternative right now. Yes, Rand?
So in the notes, I'm just confused of the wording of this. So I know that we need to include all of this, but in the notes it said, assuming all known hypothesis is true, the p-value is the probability of getting p hat a blank or extreme value cancel out.
Right, that's what we have over here. So we just put the probability detail first. But remember, we have our probability. We have our statistics, so the probability that she makes this % or less of her free throw, given the null hypothesis by random chance. You just have to include those elements. It does not have to be in that exact order. If you want, I'm sure there's a place in the textbook where it has an alternative way to write it,
Yeah.
but you just have to have those elements.
Yeah, and when you say the 4 elements that you propose, is it both, you need to both include interested in answering?
No. Conclusion has 4 elements.
Okay.
Reject or fail to reject the null. Statement about the alternative. Compare p-value to alpha. And context. So that's the 4 elements for a conclusion. For the interpretation of a p-value, you need the probability. You need the statistic or more extreme. And you need the statement about given the truth is this, right? Okay, and you need context. So there's all those details in there. Okay. So what are our conditions that we have to check?
10%.
Okay.
Large.
So 10% condition, random.
Large count.
Now be careful again with these. Is 10% about normality?
No.
No, stop making it about normality. This is about independence.
Independent.
When what?
Independent without replacement.
When sampling without replacement. Which is why with experiments, do we have to care about it?
No.
No, because what do we do there?
Assign.
We assign, right? So it's only sampling without replacement. So random 10% condition and large counts. Now remember with large counts condition, this is normality. And are we going to use p hat or p here?
P hat. P.
P.
I said P.
If we have a p, use the p. If you don't have p, don't use p hat.
You seem to have a question right here.
Yeah, I might have an answer. Okay? Yes, sir.
Maybe a super quite similar to the question, but in this kind of a situation where they reached a trial with the number of research he does, how would you do that with replacement?
Technically you can't.
And so, does that condition even matter in this specific scenario?
No. But I still need to talk about the specific detail of when sampling without replacement. But yeah, you're good with thinking along those lines. If it's an infinite population size, it's impossible, really.
This one is not p hat and p hat.
If you have p, use p. If you have p, use p. Okay. Calculate. Remember, there's a general formula on the formula sheet. What does that formula sheet say?
Z-score.
I think if you look at the formula, so one, I will say, it does not say z-square. I think it says standardized test statistic. That is important because we don't always use a Z. That'll be next unit, we'll talk about it. But it is going to work out the same. Standardized test statistic is equal to what?
Statistic minus parameter of the standard error.
So statistic minus parameter divided by, and it says standard error, but if we have P, we can use standard deviation. And so, remember we're dealing with proportions, so P hat, the parameter would be mu sub P hat, and the standard deviation would be sigma sub P hat. So then you get into your specifics. So this is our general.
Bless you, Charlie.
He's coughing. Alright, so what's the statistic we're gonna put in there?
That's what that's Charlie.
Yeah.
The P hat, okay? What's the parameter that we're gonna put in for mu sub P hat?
P.
P. Divided by, what's the standard deviation we do for sigma sub P hat?
The
Square root of,
Oh, P
P.
times 1 minus P divided.
I want to point out, because I lost this detail for many years while teaching AP Stats, the whole idea is we're building our probability on the idea of a sampling distribution. Because how many shots did she take?
Infinite.
She took 50,
50.
right? And so this is the standardized score for if she did a sampling distribution of size 50. That's what that's doing. We're calculating that where she would be in that normal distribution for a sample size of 50. Then, draw your normal curve with a, what's going to be our mean now that we've converted to z-score? 0. Standard deviation is 1, because it's a standardized test statistic. Okay.
I'm so good.
Okay. So if probability that z is greater than blank, you mark your z and you go greater than. Yes, sir? You're going to have to wait till I get them to the next part, but sure. Make sure you... How do you know which direction to shade?
Negative or positive? If it's greater than less than.
Above or below?
So where do we determine the greater than or less than?
If it's the upper
The
bound.
point of the,
Greater than or less than.
Say again?
the point of there?
But where do you see the greater than or less than?
Because if it's greater than, then
Alternative.
The alternative hypothesis tells you. Don't base it on just positive or negative, because that can get you in trouble sometimes in case you don't even have evidence for your alternative. You shade in the direction of the alternative. So you shade in the direction of the alternative hypothesis. So because I'm making up this case of greater than, we go to the right. If it was less than, it would go to the
right, left.
left. Okay? We're getting there. We are definitely getting there. Just exciting stuff. Anyone see my white for both?
Your what? It's right
check
there.
No, it was hidden by my eraser. Let me check to make sure I'm not missing anything. Yep, nope, that's good. Oh, just don't forget this area shaded right here. What is that area?
Your z-score.
No, so remember Z is right
The area.
here. Yeah, but what is that area?
Probability
Which probability are we looking at?
of the P.
Oh, at a certain point or greater, or more
Conditional
extreme.
and conditional probability.
Yeah, but that's just my p-value. You're right, it is that conditional probability, but I just want us to recognize that that's our p-value. So I'm just saying, so like if probability of Z is greater than, then we're shading to the right, right? So that, and this shading is based on the alternative hypothesis. You still haven't taken your transformations test? Is that what you're here for? Okay. Go ahead and grab a seat back. There, I guess, are the fours. Or grab a seat at the aces, and I'll print it out in a second. Okay. we gotta go ahead and get going with the next lesson. We got 22 minutes. We gotta get through some key ideas here. Okay, so we're gonna do a procedure. We're gonna do can you taste the rainbow? And so many students claim that they can taste the different colors of Skittles. And so we're actually gonna run a test with this. We got 1, 2, 3, we only have 4 groups, perfect. So what we're gonna do is we're gonna collect class data. Each student is going to taste 10 Skittles. Now obviously if you have your eyes open, you know exactly what the color is, right? And the flavors. Your job is going to be to predict what the color of the Skittle is, or the flavor of the Skittle, just on tasting.
Wait, I feel like, but like, since we know, Mr. Kenny, since we know the ones that are in there, we can just guess. Is that bias?
What is gonna happen is, you're gonna close your eyes. Okay, listen, hey, guys, you're gonna close your eyes. One of your team members is going to hand it to you. You're going to taste it. You're gonna say what the flavor was, and then the third teammate will write down whether you got it right or wrong. Then I will help you out. Okay? So, and then once you get 10 done, listen guys, once you get 10 tasted, you rotate directions, okay? We make sense of this?
Once we do 10?
Yes, once you taste 10, you rotate who's tasting the 10 and who's handing and who's marking it down. So do not tell them whether they get it right or wrong, because that can bias the data. Okay, so they need, now what are the 5 flavors? We got
Green,
green is lime.
Wait,
orange, yellow, purple, red.
Oh, those aren't flavors.
Great.
Okay, so red is actually strawberry.
Oh, that was cherry.
Nope, strawberry. Yellow is lemon. Green is lime. Orange is orange.
Okay,
Purple
lemon
is
just
grape.
biased. That's just like,
Huh?
they're both citrus-like.
They're different
That's
flavors.
gonna mess me up though.
Oh, listen, get over it. Tell me what the flavor is based on
Okay,
tasting it.
so
But can I just say
strawberry,
colors
lemon, lime.
Sure.
Okay.
Whatever makes your heart
Orange.
happy.
Okay, good.
Okay.
Okay, my take.
Alright, so let's go ahead and start collecting our data.
Is there grape?
Grape is the purple, yes.
Yeah, grape.
Alright.
Oh,
Alright.
wait, can you?
Is he on the last one? How many more does he have?
Two more, I think.
Okay.
Two more.
Dang,
Three more,
hey.
maybe. Open your mouth. Did I?
Alright, so you each
Did I
have
get the
6.
lemon ones right?
We're getting some topics.
Dang, all these lemons in here. All of that is lemon.
Is this strawberry?
Yes, I don't like
Did
lemon.
I? Lemon. Did I? Did I?
Alright. So you were 0 out of 10, and how many?
5.
You're 5 out of 10.
Oh.
Okay.
I don't know it's strawberry.
Others.
I guessed too fast.
Guess slower, please.
Oh, strawberry.
No comment.
Was it 6 and 3?
Here, Steffi, taste it. Close your eyes. But you're over here laughing at us. Close your eyes.
We're halfway done.
Wait, open your
What is it?
Red. Orange?
No, green. Oh, get out. Do it.
Alright.
Oh, no, it's this.
Green?
Do
No
it.
comment.
We have 3 more.
Okay.
I remember the lemon thing.
Alright. We gotta go.
2 more, please.
No.
What did
Come on.
Faster, faster.
It's like we only have 10 minutes of class left. We gotta finish this whole thing.
Please, faster, chewy.
There's lemon. I mean, not lemon, lemon lime.
There's
Wait,
lemon or lime, dog.
Wait, lime.
Great.
Okay,
No
close your
comment?
mouth again.
Could you see it?
Okay.
Yes.
I'm ready to work on this.
Hurry, one more. Hurry.
Alright. Sophie, did you ever get a chance to do it?
She's doing it now. She's over here laughing at us, and now.
Okay. Did Brandon finish?
Purple.
No comment.
All tastes the same, right?
Emerson, is this your last one?
It is my last one.
That's your last one.
Oh,
One right.
I already have yours too.
Last one,
If
hold on,
Phoebe
hold on.
finished, I need her data.
she got.
Okay.
Phoebe, what's her name?
No comment? Is that one? Yeah, that's one.
Okay. Alright, how many did Emerson get?
You got 6. Oh, I forgot.
He got 6?
Wait.
6 out of 10?
Yeah, 6 out of 10.
Alright. Alright, so I'm gonna cut it up here. 1, 2, 3, 4,
6 out
5,
of
6,
10.
7, 8.
I got some notes too.
Of course.
Of course you That's biased.
12, 17.
Are we done?
In a minute.
One more, because oh my gosh.
Did,
Loki?
how many feet do you
Who's
have?
got 0?
I feel like I'm missing somebody.
Charlie, you got 0 out
Yes.
of 10.
You did write down.
You said.
Great.
He did.
Kenzie, what'd you get?
Was it?
Yeah.
I got 5.
She got 8?
Who got 8?
The person that has never had Skittles before dominated all you people.
Ooh.
How many did Emerson get?
I got
That's
6.
biased.
This is rigged.
I thought you already heard my
That's
mouth.
Was yours 6?
Yeah.
Okay. 1, 2, 3, 4, 5, 6,
She has a
7,
fresh
8,
mouth,
9.
it's not.
Alright, so how many were correct? We have 12, 17, 23, 26, 29, 35, 43? How many total? I don't know where I'm missing some people, but out of 90. Alright, so let's talk through this. We just gotta go through it together. What is our procedure that's gonna be here?
Randomly select.
One
Z
interval.
interval.
So it's a Z interval,
No, one sample.
so one sample,
The interval.
not Z interval, hold up, no, not a Z interval,
Why not?
because we're not doing an
Just
interval.
sample statistics, stat test.
We're doing a Z
Z hypothesis test.
for, what type of parameter?
For Skittles.
So for population proportion, okay.
Yo.
So by the way, just like with confidence intervals, even if they just say, hey, is there statistically significant evidence, what are you gonna have to go through? Choose, check, calculate, and conclude. You gotta do all 4 of those. Notice there's a little bit more we have to do with hypothesis test, but that's because we have to include our hypotheses. Now our parameter is P, the what?
True proportion of Skittles that a person can taste.
Okay, so the true proportion of Skittles a person tastes. Okay. What is our statistic? P hat equals 43 out of 90. Beautiful. Okay. Hypotheses.
The actual proportion is.
I will say this, the Skittle, what is our alternative that we can
We
what?
cannot taste skill.
That we can taste.
That we can taste Skittles.
Oh, that
We can't assume someone can taste Skittles, we gotta collect evidence for that. Okay? Now, if you were guessing, what proportion would you get correct?
One for
Like 1 over.
One.
There's 5 options, right? So the probability, and so 0.2, I guess. So if you were guessing, you're gonna get 20% of them correct. 1 out of 5. Why are you looking at that?
Like, are we just making that up?
No. Look at the number of Skittles. Look at the colors of Skittles. Yellow, green, orange, red, purple.
Right.
So there's 1 out of 5 chance of you guessing it correct.
Oh, okay.
Okay? So, but what's our alternative? That P is,
Less than 0.2.
I thought we thought that we could
Greater.
taste. So P is
Greater.
greater than 0.2. Guys, notice we're trying to collect evidence that we can taste Skittles. We're trying to collect evidence that we can taste Skittles. Okay, so what check do we need? Random,
10%.
which we can say it's stated essentially. Is 90 less than 10% of all Skittle taste? Yeah. So there's my 10% condition. Large counts, what do I need to do for large counts?
NP.
N times P is,
We don't have the P, right?
yeah we do.
90?
The P?
Oh, I mean, 0.2.
Oh.
Remember our null hypothesis with P is 0.2. What is N?
90.
90 times 0.2 equals, what's the fifth of 90? 18?
18.
Is 18 greater than or equal to 10?
Yeah.
Yep. Am I done with large counts?
No.
Nope. What else do I need to check?
N 1 minus P.
N times 1 minus P, which would just be the other section of 72.
Yep.
That's greater than or equal to 10. got all that done. Notice the things that they want you to show here are general formula, specific formula, plug-in numbers, picture, and I would recommend it at least the specific formula and plug-in. So stat minus parameter divided by standard deviation. So p hat minus p divided by square root of p times 1 minus p divided by n.
Does picture mean global distribution term?
Yes.
What is that number next to,
Here, Charlie.
Which
Here.
number?
one minus,
Get him, Charlie.
Down here,
the next, yeah, right there.
72. The expected number of failures would have been 72. 18 successes, 72 failures.
Charlie.
90 times 0.8.
Oh.
Now, once again, I'm not doing this by hand.
And
Nope. So what was my null? 0.2?
yeah.
Then we had 43
43
successes,
successes.
90 total. We think we're greater than the null. Now, please be careful with this. So, what is my z-score in this case?
7. I can't see it. I can't see it at the beginning.
Please notice, what's my p-value? A lot of students would say 2.2, but guys, can a probability be that high? No.
Probably not.
Extrapolation?
Nope.
Wait, it's
E negative 11 means we're multiplying by 10 to the negative 11, which really means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 2. There's my scientific notation. Don't forget, e to the negative 11 means times 10 to the negative 11. Because remember, a probability cannot be more than what?
1.
1. Do not lose sight of that. Notice my z-score was what?
6.5888.
That means it's 6 standard deviations above the mean.
Well,
But that's essentially 0 for the area, right?
so practically impossible.
Yeah, pretty much, yeah.
Huh.
We're
So,
assuming that we can.
say again.
So just to make sure, we're assuming that we can do.
No, we assume we cannot. We have to collect evidence that we can. I'm going to send out some notes really quickly before that bell rings. I need y'all to hear me on this. We haven't talked about it not equal to yet, but if we were to say it's not equal to or just different from, what you would do is you would do greater than, but you would do the same amount on the left-hand side, which is why we call it a two-sided test. So we would do 2 times that area, but the calculator will go ahead and give it to you. If it's a not equal to, it hits 2 tails. Sorry, I did not have time to talk about what I need you to do tomorrow. I'll send out an email this afternoon. Yes, we got to finish this course up. Yes, we have a DYU this week. Yes. Say again.
Tell him,
Yes.
Charlie, tell him.
Well, sorry, we behind. Pretty sure y'all are, the DYU will be on Thursday. We gotta finish.
I was in the background, I was like, oh my gosh, you have to be 6 and 7 to do it.
Friday.
Then Thursday it is. Okay, so guys, please be on the lookout for that email of what I need you to do. Yes, guys, there are